You're not going to want to miss this episode of the AI Show. We're going to talk about AutoML in Azure ML, specifically building NLP models. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about building NLP models with Azure ML AutoML. There's a lot of Why don't you do some introductions here? We'll start with you, Wenqin. Why don't you tell us who you are and what you do?
Yeah, hi everyone. My name is Wenqin and I'm a PM in Azure Machine Learning. I'm driving the AutoML NLP feature and I'm happy to share with everyone the new NLP offerings in AutoML.
Fantastic. Lifeng.
Yeah, my name is Lifeng and I come from same PM as Wenqin do. I work as a data scientist, so I build the technical details and pick up the pipelines for these NLP models.
This is awesome. So let's start first with setting the ground. Everyone can understand from the ground floor. What is AutoML for NLP?
Cool. So I'm going to share some background. So for AutoML NLP, we actually provide end-to-end NLP training using the latest pre-trained large models from BERT. And we provide 3 different scenarios. The first one is for multi-class text classification, where you can classify your text data to be one category. And the second one will be the multi-label text classification, where you can assign multiple labels to a specific text sample. And the third scenario we are offering is for the name entity recognition. And for this task, you can actually extract domain-specific entities from unstructured text, such as contracts or financial documents. And with all these 3 scenarios, we also support multilingual, and you can benefit from over 100 languages. We actually support 104 languages for all these scenarios.
That's amazing. Let me stop. Let me just make sure I'm catching this. So classification for text, labeling, multi-labels on text, as well as NER, named entity recognition. Am I getting those right?
Yeah.
And 104 languages to boot. That's awesome. So you were saying, I'm sorry to interrupt you.
Yeah, I'm going to continue. In order for you to accelerate your training, you can also benefit from the distributed training we support. You can use multi-GPU or multi-node to run the NLP models, which will largely reduce the training time needed. And since this is within Azure ML, you can also benefit from all the goodness of AutoML Python SDK. You can do training and inferencing in the same time. And there's also a seamless integration with the Azure ML's data labeling service. So you can either bring your own text data and do using the data labeling service to label your data for your training use, or you can directly bring your already labeled data and directly use AutoML NLP for training. And you can also continue your training and connect this to production with the ML Ops capability with Azure ML.
This is all cool stuff. I love the idea of being able to do this automatically. But one of the things that I wanted to ask about is how is it able to do multiple languages? Lifeng.
Yeah, I think I can come to the details. So there are many models that are pre-trained with different language sources, like for English, for German, for Japanese, for Chinese, etc. So we did some experiments on different kind of data sets and then compare their speed and the final accuracy and other metrics to decide, okay, what are the models that are the best for different scenarios. Then we store these models and make them available for downloads in our system. And later, when you're using them, you can just pass your language code, and we will choose the right model for you depending on the language code you pass in. So we do all the detail for you, and you only need to tell us what kind of language do you want to use. And also, you can specify not only a single language, you can also just tell us, okay, this is a multilingual data set, which means it contains not only one single language, and we'll also deal with that.
That's really cool. It sounds awesome, but what's the user experience look like? We'll go to you, Wenqin.
Yeah, I'm going to show you guys a end-to-end user experience. So this is an example notebook about multi-label task classification with AutoML NLP. So this is using the Python SDK we have within Azure ML. So essentially, you are going to create an experiment in an existing workspace. So if you are familiar with Azure ML, you can directly do so by importing the required packages and make sure you have a workspace created, an experiment created, then you can continue with your training. So for this example, we are using a compute cluster. And for Azure ML AutoML NLP, we actually recommend you to use GPU cluster because that will largely accelerate your training. And for this example, we are using a data set from the paper system, and we are using the title and abstract of the paper to predict the category of the paper. And this category can be multiple categories. So it's a multi-label text classification. And here you are going to prepare your data, and we will need you to bring the pre-processed data here for training. And that means you will need to have your data labeled and pre-processed for using. And you can register
Just
your...
a quick pause there, if I may. If we can scroll up. So just to understand the task, when you mean papers, you mean like academic papers,
Yes.
and then you're trying to automatically categorize those papers into specific categories. Am I getting this right?
Yeah, exactly.
And when you say pre-processed, does that mean that there's going to be the text of the paper and then the labels that you can assign to it?
Yeah, exactly. So for the pre-processing, you will need to make the data to be like one text column and the other is the label column. And the label can be in different format. We support both plain text and also we also support this Python list with quotes.
That's cool. That's cool. So then it's basically the same. It's kind of like a classification problem, but instead you're going to have multiple classes that are going to be assigned in this case.
Exactly.
Cool. Okay.
Cool. And in order for AutoML NLP to run, you have to prepare a training data set and the validation data set for us to compute the metrics. And later you can also add in a test data set to do inferencing. And now we can start the run with the prepared compute, resource, and data sets. So in this example, we are going to show you how you can using the distributed training. So we are actually using a standard NC6 instance with 2 nodes to enable parallel training. And in AutoML, in order for you to do distributed training, it's actually very straightforward. You will just need to set these 2 lines of code to enable distributed training for NLP. Like for the maximum concurrent iteration, this is actually the number of VMs available in your cluster. And you can set this up beforehand when you set up your compute. And you can enable distributed and training is true. And then we are going to automatically set all the requirement framework and everything we are going to set automatically for you.
So let's pause right here. Can you hit Control Plus a couple times? That way we can make the text a little bit bigger. And then while you're doing that, just Control Plus. Just a couple of questions. So basically, you're telling AutoML to run a bunch of algorithms to do the text labeling, but on multiple machines on the number of VMs that you want. Is that right?
Yeah, exactly.
Okay.
So we actually support like both multi-nodes and multi-GPU depending on your need.
I see. And then the setting basically right here is how many max concurrent iterations can you have? Now that number is important because does the system, because I know in the other AutoMLs, and correct me if I'm wrong, as the things are marching along, AutoML will automatically stop things that are just not doing as well. Is this the case here as well?
I think I can come with some details.
Yeah.
So here, things happen in parallel because we trained the model with like a large amount of data, and now it's like we split the data onto different machines so that they can like tell the model, okay, this is how you should update yourself. So now we have multiple nodes to give this to give the model this updated information or instructions so that it accelerates things. But there won't be like things not doing well because all the nodes or machines, they are doing the same thing. They're collaborations.
Okay, so this is like a single large model, and then there's batch updates happening on different nodes to the same model. Am I getting this right?
Yeah, very clear.
That makes a whole lot of sense. I'm sorry, Wenxin, keep going.
Yeah. So once you have your distributed training set up, you can continue to set up your AutoML config. This is where you select the tags for your training. So you see here, like we have this task type, and for AutoML NLP, we are adding 3 new tasks. And for this example, we are using text classification multi-label, and we are having 2 other new tasks, which is text classification, which is for the single class like text classification. And we also have text NER for name entity recognition. And for the other settings here, this is where you have your compute target, your training and validation data set, and your label column name. And once you have your AutoML config set up, you can submit this AutoML runs by using the experiment.submit. And we are going to return you with the link to Azure ML Studio for you to monitor this AutoML runs.
That's cool. So just another question here. Are we running multiple different models, or are we optimizing and refining a good base model that we're building on top of for AutoML?
So for AutoML NLP, we are actually only training one model.
Got it. Okay.
So, yeah, you can see here, we don't necessarily need to set up the primary metrics, which is going to be used for optimization when you have multiple models. In AutoML NLP, we only train one model, and we do not need to rank the trained models. And this trained models is going to be fine-tuned based on your data set.
Got it. And that makes sense, because we found that this particular model just works really well on text, and we have a really good base model. So that's the one. And so when what you're doing when you're parallelizing it is you're making that model get updated faster, basically. Yeah. Cool. Sorry. Okay, keep going, my friend.
Yeah, so you can also directly download the metrics logged with the training run, and these metrics are computed with the validation data set you provided. So you can see here, like, we have multiple metrics can be used for reporting metrics and for you to compare with different base model or your own models. And you can also get the best run ID and best model with the get output method. So this is the end-to-end example of how you're going to train your model. And we also have the example of how you can actually inference this trained model with the script run config.
Awesome. So this is really, really cool. Are people using this? So how long does this take to run? Any other additional details you have about this?
Yeah, so during our private preview, we actually have a couple of customers who already tested with their production use cases, and they're really like the multilingual support we have, since they all have their data set in language other than English.
Of course.
Yeah, and because we are adding another layer of fine-tuning, this model actually performs way better than the base model they can directly use from Hugging Face. And that's what we are improving based on the Hugging Face pre-trained models.
This is really cool. I like the idea of, like, there's not much to do other than say, here's the data, go faster, here's more machines, and then you have a model that you can do inference on your own data in 104 different languages. Am I getting this right?
Yeah, exactly.
This is awesome. So where can people go to find out more? Li Feng.
Yeah, actually, I think, here's a link, and you can click. That is our official doc, and that will include a lot of details, like how you can set up your computer instance workspace, and also what kind of preparation you have to do for your data, and also what kind of tasks you should choose depending on your task and data. Yeah.
This is awesome. So there's the link, aka.ms, AutoML-NLP. Make sure you go find out more. Thank you so much for spending some time with us, my friends.
Yeah, thank you.
Thank you for hosting this. Thank you.
Awesome. Well, thanks so much for watching. We're learning all about building NLP models with Azure ML AutoML. Thanks so much for watching, and hopefully we'll see you next time. Take care.